Alright guys, Dr. B here. This is chapter 10, part 2. So we're going to deal with mutations, okay? Of course, I got to figure out a way to put in some mutants. Hopefully my video won't get pulled down from the internet because I put this photo in there. Anyway, very good. So there are different types of mutations, and we're going to talk about a few of these and also specific examples, some of which you should be aware of already. So the first type of mutation is a base substitution. That means that one of the bases gets substituted by something else. So silent mutation. So if something is silent, you really don't hear anything from it. That's what it means. So a silent mutation will change a nucleotide base and it has no outward effect. That means there's nothing, you don't even see, and you won't even know unless you did the genetic testing for it. A missense mutation in a nucleotide, it changes the amino acid that's coded. Nonsense, so there's an O in there, nonsense, you make a stop codon. So basically, by changing one of the C, G, A, U, whatever, you can get different effects. One is you don't get an effect at all, so it's silent. Missense means you do change it, and there's an effect. And nonsense means that you produce a stop codon, a premature stop codon. Gene alteration, so mutations that can change a gene. So you have a point mutation, a single nucleotide changes. Insertion means some DNA is inserted into a gene, which can cause problems. Deletion means you lose segments during meiosis. And frame shift, so think of like you have a frame of reference, you have a frame shift, that means maybe you inserted a gene and it shifts everything else. And that can cause you to read the different genes incorrectly, which will cause problems. Oops, sorry about that. So there are a few examples of deletion mutations. So we're I'll say they're pretty interesting. Maybe not weird. I don't know if that's the right word to use, but they will definitely catch your attention. So the first one is Cruda-Chat syndrome. It's a deletion on chromosome 5. The child will have a round face, a cat-like cry, microcephaly, meaning a small head, and mental retardation, and they're known to have congenital heart defects with this. So you can see on chromosome 5 right here, there's a section that's actually comparing these two, it's deleted or it's cut off. When we're in class, I'll play a video where you actually will hear this cat-like cry. The next one is Prader-Willi syndrome. There's a partial deletion on the paternal, meaning from the dad, chromosome 15. This usually occurs in meiosis or early development, and some of the symptoms are hyperphagia, meaning chronic overeating, and obesity due to an appetite that cannot be it's insatiable. You can't like fulfill it. It will still always be hungry. Intellectual impairment, behavioral problems such as temper outbursts, stubbornness, and compulsive behavior, such as maybe nail biting, if you will. So maybe, we're going to show you a clip from CSI when we're in class when we're discussing this. So you also have a narrow forehead, almond-shaped eyes, a triangular mouth, short stature, small hands and feet, underdeveloped genitalias. Some associations are diabetes and infertility. The next one is Angelman syndrome. It's a partial deletion on maternal chromosome 15. So you have hand flapping, jerky movements, sleep disturbance, seizures, intellectual developmental disability, frequent laughter or smiling, lack of crawling or babbling when they're a baby, minimal speech, inability to walk or balance well, tongue thrusting, disorder with sucking and swallowing, like it's not working properly. So Angelman syndrome, or happy puppet. That sounds kind of messed up, actually. It's been called happy puppet syndrome, as you can kind of tell based on the frequent laughter or smiling, and also the jerky movements, etc. Frame shift mutations. Tay-Sachs mutation, Tay-Sachs disease, it leads to an early stop codon mutation in an enzyme or in a gene called the hex A gene. So when we talked about cystic fibrosis before, they're usually a result of a frameshift mutation that deletes phenylalanine. Remember we talked about the person who was coughing a lot, couldn't really expel the mucus. They tend to get diabetes, frequent pneumonias, etc. Sickle cell anemia, it's an example of a missense mutation, so make sure you guys are aware of those. Missense, it's a mutation in the beta hemoglobin gene, and you end up getting valine, that amino acid, and you're supposed to get glutamic acid. So you don't get this amino acid at all. You get a different one. So make sure you guys are aware of these examples because I will ask you about it. Make sure you know what type of mutation is which. So very good. This is the end for this video. If you have any questions, please let me know.